Our screen is visible to everybody. So this is the last unit which we are going to start, and unit name is design of joints. In this, if you are going to see the syllabus, then syllabus is broadly classified into three types of joints. One is bolted joints, second one is welded joints, and third one is riveted joints. Out of that, in case of bolted joint, we are going to have only simple analysis and eccentric loading. Then in case of welding joints, strength of butt weld and transverse fillet weld. Then axial loaded and eccentrically loaded joints also. And we are going to see third type of joint, that is riveted joints, a type of failure on which we are not going to have any numerical treatment, because these type of joints are somewhat outdated joints, that riveted joints, but till somewhere they are using. Most of the cases we are going to use these bolted and welded joints, which we have to see in details. Again, if you are going to see the joints, before going to these bolted joints, let me ask you a question that where you might have observed this type of joints, why the basically joints are required. Yes. This is a part of assembly, right? When we are going to form any machinery, at that time various components are joined with each other. And it is not possible to have the manufacturing of total machinery as a single unit. So there are too many separate parts which we are going to manufacture separately, and they are combined together. Out of that, some are there which are going to form higher pair, some are there which are going to form a lower pair. When they are coming in contact with each other, some components are there, those who are having relative motion with each other. Some components are there which are fixed with that frame or structure of that machinery. So in that case, we need to have joint. That is nothing but we have to connect too many parts with each other, and it requires to have the joint. If you are going to see the history, then in this history of joints, initially when two sticks are connected with each other or one stone is connected with the stick, at that time that type of joint which has provided between two different parts, that you can say when human was living in caves, that is in ancient age, that history starts from with what we can say, how we go for the manufacturing of joints manually. But as nature is very great, already he has uh, created some joints. If you are going to take example of our body, then hand is connected with our body, that is means by means of joint. Flexible joint, again he has provided that joint in such a way that we are not, or it is not easily visible also. But when bones are connected with each other, they are also having certain type of joints. And these joints which we are going to see in this unit are the permanent joints. Okay. And they are not having any relative motion. The components which we are joining together, they are not having any relative motion with each other. Okay. Otherwise, in theory of machine, we have seen that there are pairs which are formed. Now, these joints are also forming a pair, but it is a permanent joint. That's why we cannot say it as a pair. The basic definition of pair is that the parts which are connected with each other, they are having relative motion with each other. So they are not coming, these joints are not coming under the category of pairs. That's why we are going to call it as a permanent joints. Now, out of that, these bolted joints are popular and widely used. Okay, because of its advantage, only one advantage we can take, because when these bolted joints are used, they are easily can dismantled and it can be easily assembled too. Okay, some disadvantages are also there that we are going to see later on, but you can say these bolted joints are widely used used joints. Okay. So what the bolted joint is? A screw joint or bolted joint is mainly composed of two elements. Okay, and it is bolt and nut. Now these two components are bolt and nut. So when they are having combinedly together, then we are going to say it as a screwed or bolted joint. Okay, the screwed or bolted joint are widely used, as already I have explained, where the machine parts are required to be relatively connected or readily connected and disconnected without damage to the machine or the fastening. Okay, so already I have explained you that these threaded joints or screwed joints or bolted joints, they are widely used in mechanical sector. Why? Because they are easily connected and disconnected, two different parts. Okay, but if you are going to see in detail, then the two separate parts which this joint is uh, having, the two different parts are nothing but nut and bolt, and that nut and bolt is important part. So we are going to concentrate on that nut and bolt, how that nut and bolts are designed. No doubt that uh, these nut and bolts are coming under the category of standard parts. That's why the standard dimensions are provided for that. That at the end of this unit, we'll see the standardization and the chart based on which the joints are connected with each other, or the bolts are selected, threads are selected. Now here I'm saying as a thread. Now this thread is one of the what we can say major or important part of this bolted joint. That's why it is also called as threaded joints also. And that in case of the other joints, that is riveted or welded joints, these threads are not coming in the picture. And that's why the threads, as we have to see in details, but our syllabus has not included all these things. So it is assumed that already you have studied the threads, and some part of the threads, the required part, that we'll study in this unit. And that threads are playing very vital or important role in these bolted joints. Okay. So when we are going to see some advantages and disadvantages of these bolted joints, at that time you come to know that there are certain advantages. Again, these are the only what we can say representative of advantages and disadvantages. You can have more than this. So I have mentioned here 4 advantages, whereas I have mentioned only 1 disadvantage. You can have number of advantages more than 4, or you can increase number of disadvantages too. So if you are going to see the first advantage, the screw joints are highly reliable in operation. What it means, that where you are going to connect two different parts of the machinery, and if they undergo to the stress, if the machinery starts and if the machinery is working, at that time forces will be applied, and that forces will create the stress in the different different bodies of that machinery. And what we are going to get is threaded joints or the screw joints, bolted joints. They are more reliable. They will not readily undergo to the failure. That is the advantage of these threaded joints. Okay. Then second is screw joints are convenient to assemble and disassemble. This is what the main or important advantage of these threaded joints. Easily with the help of spanner, you can remove that nut and bolt, and you can remove that two parts which are connected with each other. Okay. And wherever it is possible, we are recommending these bolted joints only. And to reduce the cost, we are going for the welded joints. Okay. So as and when it is possible, we are going to have the bolted joints. Also, it is called as screw joints. Screw and bolt, nut and bolt, they are okay separately or separate out by means of only one thing. Screw can be used individually, but the bolt, as we are going to see, the bolt is used with the nut, but it doesn't mean that screw don't require any nut. but the screw is having its nut in that body itself where we are going to connect it. Okay, so it is mentioned as a screw, and nut and bolt, that is the fastener it is called as. Even screw is coming under the category of fastener, and this nut and bolt, these two elements are used separately. In case of screw, nut is not required. Only bolt part that you are going to call as a screw. But that's why these joints are somewhere they are named as a bolted joint, somewhere they are named as a screwed joint, somewhere they are named as a uh, threaded joints. Okay, so uh, please take your own time for understanding this. The third advantage is that the wide range of screw joints may be adopted for the various operating conditions. That means we can have smaller diameter of the bolt to a bigger diameter, bigger fastener, where we can keep that two different parts of the machinery under very heavy externally applied load. And that load may range from 1 Newton to 1000 Newtons, okay, or thousands of the Newtons. So this range, this wide range is possible in case of this bolted joint. Whereas this wide range of applied external load is limited in case of bolt that welded as well as these riveted joints too. Now riveted joints, later on when we are going to see that riveted joints, at that time we'll see now that riveted joints are mostly outdated. Okay, they are replaced by means of these bolted joints or welded joints. Now as the technology has been improved, that's why it is not necessary to have that riveted joints nowadays. Now third advantage we have seen. Fourth advantage is that screws are relatively cheap. Okay, we are talking here now relatively cheap to purchase due to the standardization and highly efficient manufacturing process. As already I have mentioned you, this nut and bolt are coming under the category of standard parts. They are not required to design, like we are going, you might be going to study that bearing in design 2. So bearing is also a standard part, which normally designer has not to required to design it. Just we have to select, and we have seen that in case of category of belts, as the belts are, we are not going to find out the stresses which are induced in the belt. Just we are going to select that belts from the manufacturer's catalog. Likewise here also, this nut and bolt are not required to design. But basically nut and bolt is not required to design. That is not true. Basically threads are not required to design because threads are standardized. But all the dimensions which are related to the nut and bolt, that dimensions are required to design. Okay, that means diameter of the bolt, if you are going to say, then major, minor, then that mean diameter. These are the different parts that we are going to see in next slide. But that diameter has to be checked whether it is possible or whether it is going to sustain the externally applied load. And in some cases you have to calculate that diameter. And that diameter which you are going to calculate, that diameter you have to check whether it is available in standardized or standard available nut and bolts. If not, then you have to go for the next or increased dimension, increased diameter of that bolt. And accordingly, you are going to select the nut. Not necessary to have the nut and bolt separately. We have to consider it as they are considered as a combined one. They are considered as a single unit only. But that fasteners are standardized. Nut and bolts are standardized, and their manufacturing process is also standard manufacturing process. Okay, and that's why they are cheaper relatively. We are going to say it doesn't mean that nut and bolt is cheaper than the welded joints, but relatively, if you are going to calculate the other means by means of which we can connect two different parts together. Okay. In some cases, you may go for the some other manufacturing process also, like casting, like forging, okay, machining. This manufacturing process can be used to replace these joints, but they are more costlier and it requires complicated design too. That's why we are going to have these joints. Okay, take your own time for understanding what I am saying. I'll repeat it. आपण हे जॉईंट रिप्लेस करू शकतो, म्हणजे जसं स्टँडर्ड मॅन्युफॅक्चरिंग प्रोसेस फोर्जिंग आहे किंवा कास्टिंग आहे किंवा मशिनिंग आहे, ह्याच्यामध्ये आपण एक संघ तो पार्ट मॅन्युफॅक्चर करू शकतो. पण तो जर एक संघ पार्ट पूर्ण तयार करायचा असेल तर किती कॉम्प्लिकेटेड मॅन्युफॅक्चरिंग सिस्टम होईल, यू कॅन इमॅजिन इट. त्याच्याऐवजी तर तोच कॉम्पोनंट पार्ट मध्ये तयार केला आणि नंतर तो एकत्र जोडला तर मॅन्युफॅक्चरिंग प्रोसेस इझी होते. म्हणजे ही जी पद्धत आहे, ज्या पद्धतीने आपण टू डिफरंट पार्ट्स कनेक्ट करू शकतो किंवा एखादी बॉडी पूर्ण एक संघच मॅन्युफॅक्चरिंग करू शकतो, ही जी पद्धत आहे ही कॉस्टली आहे. त्याच्याऐवजी त्याच्या कम्पॅरेटिव्ह हे बोल्टेड जॉईंट्स स्वस्त आहेत. ओके, दॅट्स वाय द वर्ड हॅज बीन यूज रिलेटिव्हली चीप. Okay, these bolted joints are relatively cheap. Next, disadvantage. Now, as one can easily give me one disadvantage of this bolted joint, that if the two parts which are required to connect it together, it is required to hold that parts first, to create the hole in that part. And as you know that when you are going to create hole in any component, what increases? That the stress concentration. And if the stress concentration increases, then the load carrying capacity of that component will get reduced. Or we have to go for the higher factor of safety. We have to consider the endurance limit, okay, in case of stress concentration. And in mechanical industry, we are not designing any component for the that means it will not undergo to the static load, but it will sustain the dynamic load, that is the load which is varying with respect to time. And definitely the load which is varying with respect to time, you are going to call it as a dynamic loading, and variable stress will get induced in that component, and hence the cost of that material will get increased. That is what the most important disadvantage of this threaded or bolted or screwed joint. Okay. Any query up till now? Do you have any question? Shall we move further? Hello?
Yes, sir.
Okay. Today's strength I am going to observe as a 58 students. If you are going to remove 2, and 56 students have joined today. Very good. Why you have not shown this strength in last month or last to last month? Where we have finished some important concepts of design. Okay, let it be. Now, next part which we are going to see is the terms which are used in the screw threads. Because as already I have mentioned that in case of these screw joints, the thread is the important part. Everything is depend upon this thread. Okay, and as we are not going to design this thread, we are not going to check that whether these threads are going to fail under the shear or tensile loading or bending. Okay, that we are not going to see in this unit. But already you might have seen all these things in strength of material. But here it is required to revise the terms which are used in the threads. So here you can see the diagram in which we can see different terms which are used related to the threads. Now here the threads which are used are the V threads. We know that there are different types of threads, V threads, square threads. right? And they are basically differ by means of, just a minute. And the square threads are different from the V threads. Again, in V threads, there are also again different types. Okay, depending upon the angle which has provided. Then British threads are there. Okay, or high standardization which is used for the threads. Then in case of square threads, again there are different types based on the angle or helix angle which has provided to that square threads. Now we are assuming here simple V threads, and we are going to see the terms which are used. Now these terms may be common for the square and V threads. Okay, some of the terms. Now first of all, we'll say this normal diameter of this bolt. Okay. Now this normal diameter of bolt is important when we are going to calculate the strength of this bolt. Okay, I'm talking strength of the bolt, not a strength of the threads. This strength of the bolt is calculated based on the normal diameter. Whereas if you go further, then you will find that the valleys and trucks are created on this normal diameter. In case of these valleys, if you are going to measure the minimum diameter, it is called as minor diameter. Okay, which is mentioned here on the second part, that is nut. And the mean, if you are going to take of this major and minor diameter, or normal diameter and minor diameter, it is called as pitch diameter of the threads. Now, pitch diameter or mean diameter of the threads, it is also known as mean diameter of the threads. Okay. Now this pitch word is coming in picture. It means that the two threads which are successive with each other, okay, near to each other, if you are going to measure the same point on successive thread and distance between that, that is called as pitch. As already we have seen definition of pitch, it is a distance between two successive threads measured at the same or similar location, not same, similar location. Okay, that you are going to call as a pitch. Then the crust which is created, that is the what part on the major diameter, root of the thread, that is called as valley also, that is nothing but the minimum diameter where that root is created of that thread, where the valley is there of that thread. Then slope of the thread, that concept is nothing but the slope which has provided. That is again depend upon the angle of the thread. Slope and angle of threads are related to with each other. Okay. Then depth of the thread, that is nothing but the difference between major diameter and minor diameter. That is called as depth of the thread. This depth of thread is also playing very vital role when we are going to calculate strength of threads. Okay. Now this diagram, based on which we are going to see the definitions of various terms which are used. As already I have mentioned you that major diameter, it is the largest diameter or external diameter of the screw threads. Minor diameter, it is the minimum diameter or smaller diameter. Pitch diameter is the mean of that, and it is the imaginary cylinder on which the cylindrical screw is threaded. Okay, that is the mean of this minor and major diameter. Next is pitch. Already I explained you. It is the distance between two successive threads measured at the similar points. Mathematically, this pitch is given as a 1 over the number of threads per unit length. That will be in millimeter. Okay. Then lead, it is one more concept. Okay, it is a distance between two corresponding points on the same helix, that is called as lead. Okay, if you are going to see the diagram, then if we are going to measure distance between these points, I'll make this diagram bigger. On this crust, if you are going to take this point, and similarly if you are going to take the second point, this is called as lead. Okay, and this lead is also termed as a lead because in how many rotations you are going to achieve that lead, how many rotations are required to move from same point, similar points on the threads. Okay, that rotations, in some threads it may be achieved in half rotation, in some threads it may be achieved in two rotations. Okay, that will differ that particular screw. Okay, that is also known as stars, single star screw or double star screw. Okay, for threads. For example, we can take example of water bottle. In case of water bottle, only half revolution is sufficient to open that. Just a minute. Okay. So only half revolution is sufficient to open that bottle. Okay. Why? Because that bottle has to be, and if you are going to see threads which are over there on that bottle, okay, then you will find that 3 or 4 threads are provided. But if you are going to close that bottle, then it is going to close by means of only not one half revolution. And if you are going to open it, it is going to open with 1 or half revolution. Whereas if you are going to see the other threads or other type of threads, uh, where we can take example of any nut and bolt which is used in machinery, then 2 revolutions are required to cover one thread. Okay, thread is nothing but when you are going to wound that one string, okay, on any cylinder, and if you are going to rewound it, it will become a thread. Okay, so why? Because it is because to have the ease of opening. In case of water bottle, it is required to open it fast, whereas in case of the threads which are used in machinery, they should keep that two parts together, okay, very tightly, and easily they should not lose under the application of external load, vibration. That part should not, or that nut and bolt should not easily um, lose. That's why they are having 2 turns to complete one thread, whereas in case of bottle, we require half turn to open total bottle. So that term is related to this lead. Now next is crust. Already we have seen in diagram what the crust is, root is, then depth of thread is, where the flank is shown. Also we have seen angle of thread and slope of the thread. Okay. Next, directly we are going for the designing of bolts. Out of that, we are going to start from the simple analysis, and that is included in the syllabus. If you are going to see the first slide, then bolted joints, they are just started from simple analysis. So we are going to see this simple analysis. Now here, nut and bolt, that is fastener, is used to keep these two parts. One is upper part which is connected to the nut, and lower part which is connected with the bolt. In between that, again, this cylindrical part is also called as bolt, is inherent part. This is bolt head, whereas this is a nut. Okay, etching lines are provided to the nut. So these two parts are connected with each other and they are kept in contact with each other under the application of external force P. So when you are going to consider this externally applied force P, that force P is applied both on this nut as well as on this cylindrical board. Okay. So just what we are going to do is that in case of this simple analysis, we are going to assume that various failure of this cylindrical board, and we are going to design, just we are going to calculate the dimensions of this board. In that again, we are going to find out the external diameter and this mean that is smaller diameter of this bolt. Okay, later on this nut and threads are standard, they can be selected. Just a minute. So here the bolted joint which is shown, okay, it undergoes to the externally applied load P. Now just we are going to imagine that which type of stresses may get induced in this bolt. First of all, one can easily say that it will undergo to the tension, because these threads which are trying to keep these two parts together and this force P is trying to come out or to shear out these threads or to create the tensile stress in this bolt. So very first stress which we are going to consider is the tensile stress. Now we consider that DC is the root diameter where it will get failed, where the minimum diameter is there, right? So we are going to consider this D suffix C as a root or core diameter of the thread, and sigma T is the tensile stress which is induced in that bolt. Okay, so under the application of force, we know that this force divided by area which is undergoing for the sustaining the tensile stress is equal to tensile stress. So just we are going to calculate how much force this will sustain. So P is equal to area multiplied by stress. Area is given by pi by 4 dc square. Now here you are going to calculate the dc, that is the core diameter, smaller diameter, right? It is not a mean diameter, it is not a bigger diameter. It is a core diameter which we are going to take of threads, which we are going to take for the calculation. Okay. And if you want to calculate the core diameter, just solve the same equation, that is stress is equal to force divided by area for the diameter. So dc will be under root 4p divided by pi into sigma t. Okay. This is simple equation by means of which we can calculate the core diameter of any bolt. Any question? This we have considered when this bolt will undergo pure tensile load. It will not create any other type of load, that is shear or bending type of load. It will create only tensile load. Any question? And if you are going to, this we have calculated when only one bolt is used. If there are number of bolts, n number of bolts which are used, then external applied load will be sustained by means of this n number of bolts. Right? So just the equation which we have calculated, that P will be sustained by n number of bolts. That's why multiply this equation by means of n. So P is equal to pi by 4 d suffix c square into sigma t. This d suffix c is individual diameter. Then sigma t is the individual stress which is induced in individual bolt. Okay. Multiplied by number of bolts which are used. That will be the total external force which is sustained by means of n number of bolts. Then standard table is available for selecting the external diameter and the mean diameter of any bolt based on this core diameter. If it is not available, then this core diameter is equal to the 0.84d. That is the empirical relation we can use. If you want to calculate the mean diameter d, then normal or mean diameter of the bolt, it is a 0.84d. Okay, this core diameter is equal to 0.84d. By means of this equation, you can calculate the mean or normal diameter of the bolt. Okay, this we have considered when the bolt will undergo to the tensile load. Now next, we are going to see on the next lecture. We'll stop here. I'll take present and later on you are free to take your lunch. So before taking present, let me know if you have any query or if you have any question. Do you have any query? Hello, can you